Welcome to this video and let us make drawing the resonating structures super simple. Okay, so now you will be learning how to draw the resonating structures and I will try my level best to make it as simple as I can. Okay, so let us start it. Okay, so what is resonance? First of all, we need to know what is resonance. It is the polarity produced in a molecule by the interaction between two pi bonds or a pi bond and a lone pair which is transmitted along the chain. Okay, now don't go into this if you're not getting it. Polarity will be produced. Polarity is when there is negative and positive charges. It is polarity. Okay, whether it is a partial positive and negative charge or it is a complete positive and negative charge. So we will be moving into understanding what is resonance effect. What is resonance effect and how it impacts the electron charge density on different positions of benzene ring and how it is operated in the straight chains. So there are two types of resonance effects, just like electromagnetic effect and inductive effect. It is also of two types. So types are again two, plus R, or it is, if it is plus I effect, we say like a person gives something, he's a positive person. So if it is plus I effect, if the electrons are released by a group, it is a plus I effect. So plus R effect will also be like if a substituent is releasing electrons towards a conjugated system, it will be said to have a plus R effect. So it is electron releasing resonance effect. Electron releasing resonance effect. Now, if the group attached to the conjugated system can release the electrons towards the conjugated system, then it is said to have plus R effect. Electron releasing group should be there if it is having a tendency to release the electrons towards the conjugated system. For example, if we take this molecule, which is allyl chloride, this is vinyl chloride, not allyl chloride, it is vinyl chloride. Now this chlorine atom, it is having 3 lone pairs. Now what is the distance between the double bond and lone pair? It is 1 bond distance. So this means it is in conjugation. So the lone pairs, they can move into the orbitals of the next carbon, and so when it is there, these will be pushed to the next carbon. So now CH2, CH, double bond, Cl. Cl will carry a positive charge. This carbon will carry a negative charge. Right? Now for this, how to know whether a group is going to have a plus R effect or not? Just note it down. Just mug it up. I'm telling you a very simple technique how to memorize it. Okay. Now, if the atom directly attached to the conjugated system, has a lone pair of electrons, it will show plus R effect. If the atom directly attached to the conjugated system has a lone pair of electrons, it will show plus R effect. Good enough. Now this atom is known as the key atom. What is a key atom? It is the atom directly attached to conjugated system. Right? Now we can take the example of another molecule. Suppose it is CH2 double bond CH. Here we have NH2. So now nitrogen is having a lone pair. So it is in conjugation with the double bond. It is very much clear now. CH2, here we have negative charge, CH double bond, NH2, here we have a positive charge. Now, because the key atom, that is the atom which is directly attached to the conjugated system, is having a lone pair, that is why it is showing plus R effect. Now let us move to benzene ring. If this is the case with benzene ring, that is a group of atoms or an atom which is having a lone pair is attached to the benzene ring, then what will happen? Okay, so let us move into that. So here we have NH2. Here it is the lone pair. These are the 3 double bonds. Now we can say that this lone pair of electrons on nitrogen, it is in conjugation with this double bond because they are at 1 bond distance. Okay. Now this electron pair, it can go into conjugation. It can move towards the benzene ring. Now here will be the double bond. Nitrogen will carry a positive charge because it is giving its electrons. Now because these pi electrons, they have shifted on this carbon, it will carry a negative charge. Now we said that it will create a polarity in the molecule. So this is how it creates a polarity in the molecule. Good enough? Okay. Now while writing the resonating structures, you need to go in one direction. So now we have started in this direction. Okay. So now we will keep moving in that direction only. We will not go back from here. Okay. Now this negative charge and this double bond, they are also at 1 bond distance. So they are in conjugation. So this negative charge will move in between the carbons, and this pi bond, it will move upon the carbon. So what happens is negative charge moves from upon to in between and takes the form of a pi bond, and the pi bond moves from in between to upon and takes the form of a negative charge. Cool? Okay. So now here it is NH2 positive. Now the negative charge will be here. Now see the next conjugation. Negative charge is in conjugation with the next pi bond. So it will move here. In between to upon to in between. So this will make it easier to draw the resonating structures. Now back to normal, right? So the positions of double and single bonds have changed. So these are the 5 resonating structures in case of aniline. So this is aniline. So you can practice any number of structures. You can take OH group. Now OH group, oxygen is having a lone pair. That is the key atom. That is the atom which is directly attached to the conjugated system, is having a lone pair. So it will show plus R effect. So you can draw all the resonating structures. I'm just showing one. Like this. Now if we move to halogens, halogens are having 3 lone pairs of electrons. Again, they will be showing the plus R effect. Fair enough? Okay, now let us move to the minus R effect. Okay. So in case of minus R effect, again, minus R will be if a person takes away everything from you, you say it's a negative person. So now the group which will be directly attached to the conjugated system, it will be taking electrons from that conjugated system. Okay, so this will happen when an electron withdrawing group is attached to conjugated system. Now, so what are the different examples? It is NO2, it is C triple bond N, COOH. So these are all the electron withdrawing groups. Now do not confuse this resonance effect with inductive effect. Inductive effect depends upon the electronegativity. Resonance effect will depend upon the availability of lone pair. And now minus R, I will be explaining how to go for the minus R effect, or how to see whether the group is going to have minus R effect or not. Okay, now if we go with the CN group, C triple bond N. Now this carbon atom, it is triple bonded to nitrogen atom. So now you note down one pointer, which is very important. If the key atom, that is the atom which is directly attached to the conjugated system, has a multiple bond with another atom which is more electronegative than it, multiple bond with another atom which is more electronegative than it, then it will show minus R effect. Now what is the key atom here? It is carbon. Okay, now it is attached to more electronegative atom which is nitrogen through a multiple bond, that is a triple bond, right? So it will show minus R effect. So now what will happen? It will attract the pi electrons towards itself. Now these pi electrons, they cannot move towards carbon because carbon is less electronegative. Now this triple bond is taking the electrons towards nitrogen, and there is a conjugation between this triple bond and the double bond. This triple bond and the double bond. One bond distance is there, right? So this can move here. Okay, now carbon, now double bond nitrogen. Nitrogen will carry a negative charge because pi electrons have moved on to nitrogen. Now, because from this carbon, electrons have moved away, it will carry a positive charge. Okay, so next, see this positive charge and this double bond, they are in conjugation. So this bond can shift here. Okay, now so here it is double bond. So sorry, I have drawn a single bond here. It is a double bond. Now there, this will be like this. Again, the next pi bond, it is in conjugation with the positive charge. So here you will be drawing it like this. Double bond C, double bond N. Nitrogen will be carrying a negative charge. So here it is. In the last step, this negative will be coming back, and this pi will be going back into the benzene ring. And Here we go. We are back. Good enough? Okay. So this is how we write the resonating structures. Minus R effect. So you can take up NO2. Now this is your assignment. You will be telling whether NO2 is having a plus R effect or a minus R effect and why. So this is the assignment. You need to put in the comments below whether it is having a minus R effect or a plus R effect and what is the reason behind it. And I will see you in the next video now.